Hello friends, आपको नमस्ते. So to in this video, we will train faster RCNN on a custom dataset for detection of beverage detection. So let me run this cell or installing the Overflow because we have to download the dataset from the Overflow. So the dataset is in a YOLO format, and the name of the dataset is beverage detection. Okay, now I will change the name of the you can say dataset from the old name to the new name. So this is the old name, this is the new name. If the old name is exist, it means the name is not changed. And also one thing is that was the part new name is also not exist. Then only we can say that the name is not changed. Then only we can change the name. Otherwise, already exist, already name we can say. Now let me run it. You can see this dataset name is changed. Now these are the libraries which we use is torch vision, data loader. Data loader is basically used to make the number means all the images into convert all the zone images into number of batches. Okay, this is a transformation. It means suppose we apply some data augmentation or not. Okay, CB2 NOS you all know. So now let me run this cell. Okay. Now this is a custom data cell. This is a required of the custom data cell so that we can return the images and bounding boxes and labels and all those information of the single image in a tensor formats. Okay, so let me, if you get killer clarity, you can read this three line. Okay, now this is, you can say, custom data set class which we have created. This is the init function. Okay, this is self image directory. This is annotations, means the list of all the annotation file name presented annotation directory. And this is a transformation. Is initially it is none. Here we are initializing the variables. Okay, after that we will give means we want to know that how many number of images which we have, or you can say number of annotation. So we will use length function. For that we use just give me the length, and it will return the number of images to me. Now get item means get a sample image plus target by index. Okay, for a single image, this all thing is happening for the single image, so don't get confused. Here first we get the file name using the index. Using index value we will get the file name. After that we will get the image path. How we can get the image path? For that purpose use os.path.join, then the self.image directory. Then annotation -4 means we do not require last for character, that those character will be .txt, and instead of that we use .jpg. So this way we create the image path. After that we will read that image, and here we are reading the image using a cb2. So we are reading the image into the bgr format. So if the image is not found, it will throw the error. After that we convert that image into the rgb. Here we are converting the image into rgb using a cb2 color formula. Sorry, not formula, function. Then we required a height and width. Why we are requiring the height and width, I will explain to you later in the code. Okay, so don't get confused, worry. Now how we can get an annotation file path? For that we use just os.path.join, then annotation directory, and annotation file name which we get using a index value. Then list of all, we want to store for a single image we want to store all the bounding box details and the labels. So how we can do that? For that purpose we create two list, boxes and label, empty list initially. Then we will open the annotation file with read mode as f. Everything will be stored in the f, and when we loop over f with the line by line, I want to read each dimension, you can say each dimension values. So for that purpose, first I will want to retrieve everything in a list format. So how we can do that? For that purpose, I will use this line dot strip dot split. Give me this way. Give me data like this way. 0 is just for the index. This is just for the assume. And we have downloading data set in YOLO format. So second value will be x center. Then third value will be bicenter, and same way x center and y center, then the width and then height. Okay, this all thing is in a list but in a character in a string format. Now we have to first see YOLO format is class id x center y center width and height, in a normalized. Okay, in a normalized value, these values are normalized, so we have to convert into pixel values, pixel label values. So how we can do that? First we get the class id. First value will be the class id, and we have to convert that into an int. After that we have to retrieve this x center value, and if I will use instead of float I will use int, then that value will get me zero value. It will just give me zero, and zero value will give me. But we do not require the entire float value, so for that purpose you have to convert that value into the float. From string to float, then I have multiplied with the width to convert that into pixel level value. Same way for the y center, box width and height. And then how we can retrieve this x's and x min, y min and x max, y max value. X min and y min, as you can see, top left corner coordinates value of the bounding box, and x max and y max are the bottom left corner of the bounding box. And see, when you will get x min, how we can get x min? Just use x center minus box width divided by 2. Same way for the y min, and same way for the x min. X min and y max, here we are adding it. Okay. After that, we append those values into the boxes list, and here you can say we are appending. You can say here I'm just using class index plus 1. Why I'm using class index plus 1? Because zero index value is always fixed for the background, because for the model which we are loading as trained on a Coco data set, pre-trained on a Coco data set, and in Coco data set, zero index value is always fixed for the background. So that purpose we're using class index plus 1. Now after that, we convert everything within a tensor, boxes and labels. If any transformation is required, like resize to sensor or augmentation, it's applied to the images using if dot self. If you can say initially it is none, here you can say, see where it is going. See, initially it is none. After that, we apply the transformation to it. Then we just make a list of not list, we make a dictionary which give me boxes and label details for the single image. Then we return it the image in a target. Now let me run this cell. Oh, now let me show you data.yml file for the beverage detection. Okay, so the number of classes which we have is, we have three classes. We are detecting bottle, can and glass. Okay, but number of classes here we are using 4. Why? Because one is always fixed for the zero index value is always the background. So 4 is basically including 3 plus 1 is for the background. Now you can see this is a pre-trained model which we have uploaded. The model which we are using is faster RCNN torch from where we are uploading it. Torch vision model detection, we are uploading faster RCN ResNet50 FPN. The weight file which we are using is Coco v1. Now let me run this cell to show you the model, that why we are have to change this model according to our number of classes. See, in a box prediction, it has classification code or bounding box prediction. You can say out feature is 91, because Coco dataset had 91 classes, so its out feature is 91. And same way for the prediction. When you have 91 classes and when you multiply 91 with the 4, because for the prediction box prediction we have to predict for each class we have to predict 4 values. Uh, 4 values. So when you multiply each class with 4 values, and 91 into 4, you will get 364. That's why it's having out feature 364. Now it is according to Coco dataset. It is this head. Now we have to change this head. So first thing we have to retrieve in feature. Okay, so how we get a number of input feature to get a final classification layer. So how we can get it? First, go to the model, go to the ROI head, go to the box predictor, go to the class score, and you will get the in feature. So we're going to the model, we're going to the ROI head, we're going to the box predictor, we're going to the class score, and we're going to the in feature. This way we retrieve the in feature. Now, after that, we replace this ROI head.box predictor according to our predictor. For that purpose, we use faster RCNN predictor, and we are just passing two parameters. Here, first parameter is in feature and number of classes which we are having. So this will replace the head according to our number of classes. Now when I print this model, which we change according to our number of classes, you can see this out which is going to be have 4. And here when you multiply 4 into 4, you will get 16. Okay, so this way we have changed the number model according to our number of classes. Now we have to create a data loader. How we can create a data loader? First we have to get a train image directory, then a train annotation directory, then a train annotation which give me the list of all the annotation file name present at annotation directory. Then we have to create the data set, so not data set, we have to create the object of the class which we have created. And here we can say we are applying the transformation transform into two tensor, which convert image to PyTorch tensor. Basically, it convert all the pixel value to in a normalized way, and also uh, it changed the dimension from HWC to CHW of the image. Here we getting the as train image directory and a train annotation directory. This way, and now we have to use the data loader. For using the data loader, we pass a train object, then the batch size, the shuffle, and the callback function. Why using callback function? Because it's possible that the images is not different size, variable size, or you can say variable size target. We can say. Now this is a create data loader efficiency load batches. It will load the batches, means load the images into the batches for the training purpose. Now we want to know how many number of batches which we have. We have 151 batches we have, and each batch has four number of classes. Sorry, and each batch have four number of images. Now we are applying here. We are initializing the optimizer and optimizer here. So and learning rate. So here setting the device. Why we using a device? Because otherwise use GPU. Why we are setting the device? Because everything images and targets and model has to be on the same device. So we want to know that the processing is which is happening with is happening on which device, whether it is happening on a CPU or on a GPU. So to get to know how to get to know which we for that purpose use torch vision dot coda dot available. If it is available, device name will be to coda, otherwise it will be CPU. Then we will move to the model to the device. Then we want to know the list of all the we have to make the list of all the parameters which is trainable during training. So how we can do that? For that purpose, we use for p in model dot parameters, and if p dot require grades, it means if p dot require grades, it means if that attribute is true, it means that parameter is trainable, and will be that make the list of that parameters. After that, we make an optimizer, and optimizer is basically used to update the weights values in a during training. So that purpose, the optimizer which we're using SZD, then the learning rate be passing the parameters which is trainable, then the learning rate. The learning rate value we're using is 0.001, which is ideal, and momentum is 0.9, which is basically I use 0.1 because so many hit and try method. I use mostly 0.001. It's very effective. Then I will use number of epoch will be 10, but right now I just want to use one epoch because I already have a model registered on 10 epoch. I will show the result of that model directly, so don't worry. Now we want to get to know number of classes using a YML file. We directly want to know number of means we want to get the extend the we want to retrieve the class name list. So how we can do that? So for that purpose, I just give the path of the data.yml file. This YML path, we go to here. We will open that YML file in read mode, and this line give all this line means expand data in this data variable, and after returning data names, all class name is stored in this class name list. It give me the list, and after when you print it, you will get a number of so not number of classes, name of all the classes. This is portal canon class. Let me run it cell. Now we have to check the data loader that the class which we have created is correctly creating the bounding box around the object or not. So how we can do that? First we have to get the iterator. How we can first we have to use the iterator here. We have to create the iterator. Then we have to use next, which give me the images and target. This images basically contain four images, and this target basically did contain the detail of four images, means bounding boxes and labels. And we have to plot two images. So we use this plot the subplots, means one row, two column, means two plotation. Figure size will be 12 by 16, 12 by 6, and figure basically representing the entire subplot. X is just for the iteration purpose. Okay, x dot variable basically converted into 1D 2D from 2D to 1D, and just want to plotation of two images. So you have to loop for two times. Then I already told you above in a code that when you use transformator dot to tensor, then it will convert the image dimension from HWC to CSW. So to and during plotation, we have to convert that from CSW to HWC. For that purpose, we use idx permute permute 120. It will convert. Then we have to move the image to CPU. Then you can say that image. If I will not if I will not see, if I will not see, when you have used a transformer, it basically convert the image pixels values to the normalized. Okay, so we have to those value into has to be in a numpy, sorry, not a pixel value, because when you will use two tensor and transformation, then the image is in a tensor format, so that but during for the plotation of the rectangle and it put text on a images, we have to convert it into numpy, so that's why we're using here numpy. But using of this line, why we are using this line? Okay, because all values in a image is in a 0 to 1. So let me show you. Okay, wait for the second. All values are in a 0.1 because we have applied that transform here to the images. Okay, so wait for the second. See, all values are in a 0 to 1 range, but for the plotation we do not need this range, we have to need this range 0 to 255. So how we can do that? We have to multiply each value with the 255 and just make the copy of that image. Then we want to retrieve the information for a particular image. So how we can do that? Just use target dot boxes. First we have to use IDs. Give me the give me the ID means retrieve the target, or you can say retrieve the information for that particular image. After that we will use box and label. Give me the labels and boxes for the particular image. And here you can see using CPU and NumPy is the same reason, but which I have explained you above. We will zip over in box and label. Why we are zipping here box and label at the same time? Because each box bounding box has its own label. That's why this line give me the color, randomly select the color. Then we will map xmin by min and xmin by max using this line xstrip.int. Then we plot the rectangle over the images using this rectangle, CB2 rectangle. You already know what is use of the CB2 rectangle. Just pass xmin by min, xmin by max, and color and thickness. Then we have to put the text. Here we see one thing which I have to explain here is put text. Here we label dot -1 because zero index value is already fixed for the background. And when you and you can see in a class name list, zero is for the bottle, so that's why we subtracting one for the label. After that we plot that image. Now let me show the plotation. Okay. Yes, it is glass. It is glass. Let me run it again. Each run it give you different image. Okay, I think the most of the images are for the glass. Yes, most of the images which we have is for the glass. Okay, bottle, can, yes, it's better. Now it's better. Now this is a training part. For the training we are using TQDM to make the visualization perfect. Okay, now train loss basically store loss for each epoch. Now we will iterate over the using a for loop. We according number of classes, number of epoch, we iteration. We will use for loop. The first line which we display is this line, starting the training of epoch plus 1. And here the model has to be on train mode, because when the model is in a train mode, then only that wait file will get updated, otherwise it will not update. Then variable accumulate total loss for this epoch. Okay, accumulate total loss for this epoch. That's why we use the training loss for zero, and initially its value will be 0 0. Here we initializing the TQTM. How we initializing it? So first we have to get the train data loader, then the length of this, then the line which we have to display, then the label will be false. Remove bar after epoch, but we do not we want bar, label will be true. Okay, then be progress bar. Then we have to iterate over this progress bar, the variable which we have created. It will give me the images and target means batches. When at each iteration it will give me the image and target batch. Okay, now make sure that everything model and target or images has to be on the same device. So this line give me this thing means this two line decided by the means settle this thing. And here we just passing the image and target. Passes image and target to the model return a dictionary of the losses. After getting the dictionary of the losses, we want to know we want to add all losses in single variable. How we can do that? We will iterate over this losses dictionary dot values, and each loss value will be sum with the loss, and everything will be stored in this losses variable. After that we will clear old gradient value, because when because the new weight formula is like this. New weight is equal to old weight, then learning rate into means plus or minus, and I don't recognize the formula, but it's like a plus learning rate into gradient. And see, gradient value is basically decide the on which direction weight has to be go to make the loss minimum. Okay, so if the gradient value will not be set to 0 for each batch iteration, then a previous batch iteration gradient value will affect the new weight, which affect the training also and affect the result also. So that's why optimizer dot zero grade basically clear the gradient value. Then losses dot background basically calculate the gradient value, and optimizer dot step basically update the weights value. Now here we losses dot item, and losses dot item basically give me the loss for each batch, loss for single iteration, you can say. And each batch loss is not a store, added to this train running loss which we have created. After that, to compute average loss for the epoch, we will use this formula. After that, we append that epoch loss to the train loss, which is store the loss for each epoch. Then we display the, you can say, loss. This way it's happening here, you can say it's working. It will take time. Now this is a plotation for the tan epoch. This is a plotation for the train loss for tan epoch, you can see it. Okay, here just I just use a plotation here, epoch log, then plot dot subplots, axis dot plot, then x label means x values, y values, r minus. Okay, red line means straight line. Train laws label be this in x label, y label, title isn't show. This is just a simple thing. Now how to save the model? We have to save the model. So how we can do that? Just give the path, then torch dot save model dot state dict, then the path. The model your model will be saved. Now we have to test the model. So how we can test the model? First step, set the device, which I have explained why there is a need of set device. Number of classes which we have is 4, 3 for the custom class, 1 for the background. Now this thing is, I have explained you above that how we can load the model, pre-trained model. Okay, after that we will load the model which is trained on custom dataset, means above. So how we can load those weight files? So how we can do that? For that purpose we use model dot load state dict, then torch dot model, then map location will be CPU. Now here the model has to be an evolution, because this during evolution the weights will not change. Those value will not get changed. We have only 3 classes. So for one class is single, first class its color will be red, second class green, and this way blue. And for the protection of 16 images we use 4 rows and 4 columns. And during before training we have applied transformation. During testing time it's compulsory to add transform to the images, otherwise the testing will throw error. This is a test directory, and here we make the list of all the images name present at particular directory. Now for the protection 16 images we have to loop over 16 times. Then we have to select the image path. How we can select the image path? So this is os.path.join test directory, then randomly select an image file name from using the test images list which we have created above. Okay, now same way we see, though it's not required, we open the image path, then unsqueeze. Why there is a use of this unsqueeze here? Because during testing you have seen that we are passing the images in a batch format. So during testing time same dimension is required. So how we can do that? We use the unsqueeze 0, which add one additional dimension to the image like this. It will give me this thing, h w c, then batch. It will give me this dimension. Okay, which is required during testing, because at training part we're passing the image into batch. So during testing it's compulsory to pass the image into batch form in a batch format. Okay, but batch value will be 1. And array convert to OpenCV format, because we have read the image into using a pill, so it's in a pill format. So we have to convert an image to numpy format to add to draw the rectangle over it. Okay, it's not required. Image PC, it's not required. Okay, Now we have torch.noGrid means gradient will be not there, no operation of gradient will be there. Here we just we pass the image and zero index value because we passing the single image. To get the result of single image we use zero index value. This way we retrieve all those values of boxes, labels and scope for the single image, all information. And why we are using .cpu.numpy, because everything is might be possible that everything is on a CUDA, so we have to make sure that everything come back to the CPU. And .numpy, why? Because all those values which is boxes and labels is a tensor format, so we have to convert that into numpy, so that's why we're using numpy here. After that, I have already explained that each bounding box has its own label and score, so we have to use zip for each, for those three values. And we only plot those bounding box whose score is 0.8 and label is not equals to 0. Now we will map all values to x1 y1 and x2 y2 value, and here we will getting the label means color, using class color for each class. Image CB, why? I think so there is one problem. I have image CB, this one CBD color RGB to BGR. Oh yes, image CB, I think so it's not required. Let me comment it, and instead of image CB it will be image NP, image NP, and here will be image NP. Okay, image NP. See, okay, everything is working. So image CB2 rectangle, we plot the rectangle over the image, color, thickness, then putting text will be this one, class name, label -1, you already know the class name, zero is value is fixed for the bottle, so label -1 give me the correct label, because zero value is always fixed for the background, so label might be 0 or something else. Okay, so I try to correct getting correct label, we'll subtract 1 here, the score will be this, so this way we plot the text. Okay, this is the coordinates value, we plot the text, plot the text over the image. This is a font, this is a scale, color, thickness, this is line AA, and here we plot the image. We are not plotting the image CB, we are plotting image NP, and then axis will be off. Now let me see that training is completed or not. Yes, training is completed and model is saved. Now let me show the result of the model, which is just train on one epoch. Okay, it's working on some images but not, mostly it's not working, and I think so it's working on glass better, because I think number of images for the glass is more as compared to uh, can and a bottle. Okay, now let me show you the result of the model which is trained on 10 epoch. Wait for it. So let me upload that model. Now let me show you the result of the model which is trained on tan epoch. For that, let me run this. I already upload the model and change this line. You can see model.state, load that model, beverage.pth. Now let me run this cell. Okay. So here it is. Glass. This is a can. Glass. And here it is a bottle, glass. Yes, it's working very well, but in some images not working very that much, but it's pretty much working very very good. Okay, you can increase the epoch, and also you can increase number of images with annotation, so you can get a better result. But it's working very well. You can download this weight file, or and use anywhere you want in your project. So this is your training the faster RCNN custom dataset to detect beverages detections like can, bottle, and glasses. If you gain any knowledge in my from my video, so please like, share, and subscribe my channel. Thanks to all.